So David is a professor in the Department of Medicine at McMaster University and previously a professor of psychiatry at Bangor and Cardiff Universities in the UK. He studied medicine at University College Dublin, Ireland, and at Cambridge University, and is a former secretary of the British Association of Psychopharmacology. He has written over 230 peer-reviewed articles and 24 books, including The Antidepressant Era, Let Them Eat Prozac, Mania, Armageddon, and most recently, Children of the Cure and Shipwreck of the Singular from Samizdat Press. His main areas of research are the adverse effects of treatment, clinical trials in psychopharmacology, the history of psychopharmacology, and the impact of trials and psychotropic drugs on our culture. David, thank you so much for taking the time to chat with us today.
And it's great to be giving this talk at the invitation of Aaron Kesselheim at this Harvard Group for Law and Medicine. This is going to be a very conservative talk. I believe very strongly in the medical model and in the need to evaluate our treatments as well as we can. I'm going to start you off here with the Tobin versus SmithKline Beecham civil litigation. And this happened after a man called Don Shell had been put on Paxil and 48 hours later shot his wife, shot his daughter, shot his granddaughter, and then killed himself. The man you see here in the slide is Ian Hudson, who at the time was the chief safety officer for GlaxoSmithKline. And he's been asked, can Paxil cause people to commit suicide? And the answer is we in GSK, like all companies, practice evidence-based medicine, and we use randomized controlled trials to evaluate and approve drugs. And our RCTs show that Paxil has no adverse effects at all. The jury in the case took a much more evidence-based medicine point of view, and they dismissed Hudson's point of view. They thought it was evident that Paxil had caused this man to kill his family and then kill himself. Hudson's view, however, is the one that has prevailed in the longer run. It's ensconced at the top of FDA and EMA and WHO, at the top of groups like MRCT in Boston and Vivli, and I'm sure Joe Biden and the Pope, if asked about the best way to evaluate drugs, their advisors would tell them to answer RCTs. This is the way, the truth, and the light. Hudson himself, later, shortly after this trial, became the CEO of Britain's version of FDA. So, Hudson's view goes back to this strange man here, Ronnie Fisher, almost 80 years beforehand. And Fisher was not particularly good with evidence. When the evidence came out that smoking could cause lung cancer, he poo-pooed it. He never ran a randomized controlled trial and never had anything to do with medicine at all. So it's fairly astonishing that his views from 80 years ago have had such an impact on the way we think and live now. And it was because of two things, randomization and statistical significance. Fisher was in the business of trying to characterize expert knowledge. And now we've all got expertise on certain things like parachutes. Everybody knows that if you have 40 guys up on a plane and push them all out of the plane, having given 20 of them parachutes and the other 20 not, that you'd expect at the end 20 living guys on the ground and 20 dead bodies also. Fisher said that's true, and the expertise we all have in this case is right, but trivial things that we haven't thought about, perhaps, like maybe some of the guys had webbed armpits or webbed feet, could make a little bit of a difference so that it wouldn't be quite as sure that one of the guys without the parachutes would end up dead. Or the other thing that could make a difference was chance, that a strong gust of wind could blow one of the guys without a parachute into a snow-covered tree and he'd live. And this has happened. So Fisher was saying, if one time out of 20, one of the guys without a parachute lives, we still think the view that parachutes save lives is expertise. And we've taken care of trivial things by randomizing. Somehow, though, these ideas of randomization and statistical significance transmuted into something mystical that was going to let us know the truth about the drugs we use without us really knowing the truth about the drugs we use. Randomization is not a way to control for ignorance. Fisher's expert was like Robin Hood, who 19 times out of 20 could split the arrow that had previously landed right in the middle of the bull. Robin Hood knows what he's doing. Trouble is, with the randomized control trials we do in medicine for antidepressants and all of the drugs we use across medicine, the results look much more like this, which is, when we're doing RCTs, we're doing nothing like what Fisher was trying to work with. We've got to rethink what's happening with RCTs. And perhaps the way to start rethinking about it is to go back to the first randomized control trial that happened in medicine. That was run by a guy called Tony Hill, who curiously was the person who put the link between smoking and lung cancer on the map. Hill and Fisher didn't get on. Hill, investigating streptomycin, introduced randomization as a method of fair allocation. There was nothing about controlling unknown unknowns or confounders. It was just, a fairly trivial thing. And one of the things you need to know is that there had been a prior non-randomized control trial, which had been conducted at the Mayo Clinic, which had reported 3 years earlier saying streptomycin does work. But it comes with problems. That is, you can get tolerant to it quite quickly, and it can cause problems like deafness. The Mayo Clinic trial was much more informative than the RCT was. Now, here is Hill, 20 years later, talking to a group of doctors about control trials. And he's saying, we had to do control trials in the early 1950s because nothing worked. We wanted to try and get certainty about the one or two things that it may be useful to use. But now we've got lots of new drugs, antidepressants, antipsychotics, hypoglycemics, antihypertensives, chemotherapy, cortisol, all sorts of new and wonderful drugs, all brought on the market without any RCT in sight. And, we still need to do RCTs in order to establish which of all the drugs we have is the best drug to use for people who are depressed, for instance. Now, RCTs don't do that for us. There's no such thing, in a sense, as a best drug. The other thing Hill is saying to the doctors, though, is that randomization's not important. And he's saying double-blind isn't important. The important thing is a doctor looking at what's happening to the patient and evaluating the drug. And if the double-blind gets in the way, well, get rid of the double-blind. The other aspect of this is he's saying randomized control trials give us average effects, and this isn't terribly useful. One of the other things he points out is that, it's very odd, but the people going around the place these days telling doctors to practice according to the control trial evidence, well, they're pharmaceutical companies, and who would have expected them to be saying that? Finally, he says, look, RCTs are useful for establishing one thing, like if we're looking at whether this drug can be therapeutic in a particular condition, and just focused intensely on that, the RCTs can help us with the answer. Now, there was a trial that happened 5 years before Hill said all this that actually brings out his point beautifully. And it was run by Louis Lassagne, whom you see there on the right, who had done all his formative training in Boston, and who'd run this randomized control trial of thalidomide in 1960, placebo-controlled, and found that it worked effectively as a sleeping pill. This RCT did what Hill said RCTs can do. It missed the nausea, the agitation, the suicidality, the sexual dysfunction, the peripheral neuropathy, all these SSRI-like effects that thalidomide can cause. And 2 years later, when the thalidomide crisis blew up, and Louis Lassagne was at the heart of trying to revamp the regulatory system to make us safer so that things like this wouldn't happen again, he suggested that companies should be forced to do RCTs to prove their drugs worked. Forced to do the thing that thalidomide had sailed through without a problem. Louis Lassagne is the person who's responsible for us doing RCTs these days, much more so than anyone else. Now, advocates of RCTs say that they can help us establish cause and effect in a way that no other study design can do. Now, Imipramine is the first of the antidepressants brought on the market in 1958 without controlled trials, like all of the other drugs brought on the market during the 1950s. And it's a much better drug than the SSRIs. It can treat melancholia, which comes with a high risk of suicide, which SSRIs can't. But you need to know that a year after it came on the market, a group of experts, like Fisher's experts, having used it, were met together to talk about its benefits, which they thought were great. It means we could use much less electroconvulsive therapy. But also they pointed out that this drug can cause people to commit suicide. You put some people on the drug and they become agitated and suicidal. You take the drug away and the problem clears up. You reintroduce the drug and the problem comes back. So we're going to do a notional RCT, a thought experiment like Fisher, a thought experiment because there were no RCTs like this done on imipramine for melancholia, and we'd expect the results to look like this. This drug that can cause people to commit suicide looks like it in this RCT that it just simply can't cause suicide at all. You would say on the basis of this RCT, this drug does not cause suicide. Now, in the case of the trials that brought the SSRI group of drugs on the market, the data looks much more like this. The trials were done in people who are mildly depressed at no risk of suicide, and the suicide risk of the drug stands out in this case. If we put imipramine into these trials, and this is not a thought experiment because we did do it, it was used as a comparator to the SSRIs, the imipramine results look exactly the same. So we've got one set of RCTs showing that imipramine can't cause people to commit suicide, and another set of RCTs saying it can cause people to commit suicide. The point being that RCTs, just because we do an RCT, we don't get the right answer. And the problem here is that most people see these trials as drug trials when in fact they're treatment trials. And every time we're treating a condition with a drug where both the condition and the drug can cause a superficially similar problem, RCTs don't give us the right answer. They don't get rid of the confounding. They make things worse unless we know what we're doing and make judgment calls about the kind of suicides that happen in the trial. The RCTs don't answer the question for us. If you want to remove the confounders, it's not about doing an RCT. It's about doing a drug trial where you give SSRIs to healthy volunteers, and you find that the results look like this. Companies did these trials before they brought the SSRIs in the market, and what do you know? Healthy volunteers have committed suicide, become suicidal, had sexual dysfunction, have become dependent on the drugs after only a week or two, so that it's hard to get off. And this helped companies work out, well, you know, how to run their treatment trials so that these problems didn't show up, as you'll see. So one way to encapsulate the points I've just made is this, that if we ran an RCT of randomly applied plaster casts to a broken limb so that, you know, the plaster cast might not end up on the limb that's broken, that trial would show plaster casts beat placebo. But if you were to practice evidence-based medicine like this, rather than evidence-based medicine, which is, it makes sense to put the plaster cast on the broken limb, you wouldn't be practicing good medicine. Now, that takes care of randomization, to some extent anyway. The other thing that Fisher introduced was statistical significance, this 1 in 20 chance that chance may interfere with an expert's view. 200 years ago, well, first of all, this is the James Webb Telescope, which has produced wonderful images of the universe and the early universe that lots of people have thrilled to. 200 years ago, the telescopes that astronomers were using weren't as good as this, and they often found it hard to distinguish whether they're looking at one star or two stars. And Gauss came along and said, well, we can solve this problem. If it's measurement error from poor instruments, you'd expect the errors to distribute in a normal distribution. So just build a confidence interval, and if the next measurement falls outside that, then it's likely coming from a different star rather than the first star. And confidence intervals rushed into medicine in the 1980s, where people said, we have got to get rid of statistical significance testing. It's just not what we're doing in medical trials, where we're not experts, we're ignorant, we estimate what we think we're seeing. So all of these experts on the right-hand side, some of whom came from Boston, we're saying pretty much the same thing. Statistical significance testing should be got rid of completely. Now, confidence intervals look a little bit like this. Here are two confidence intervals for two different drugs, red and yellow drug, and they're both falling on the right-hand side of the line, black line through 1.0, which indicates they're causing a problem. Let's say they cause a lethal problem. They kill you, okay? The confidence interval for the red drug is very tight and precise, and all of the data falls to the right of the 1.0 line. At least more than 95% of the data falls to the right of that line, which is the same as saying it's statistically significant. In the case of the yellow drug, it looks like there's a bigger risk, but there's a wider distribution, and less than 95% of the data falls to the right of the 1.0 line. The conventional wisdom is that if we just put a few more people into the yellow drug trials, we'd be able to make that confidence interval tighter and we'd really know what's going on. So if asked to take one of these two lethal drugs, that conventional wisdom is you should take the yellow drug because we know the red drug causes you to commit suicide. We don't know the same for the yellow drug. My view, of course, is just the opposite, which is that if I had a choice of which drug to take, I would take the red drug because the likeliest estimate of the risk of you dying with the yellow drug is much higher. But I'm going to show you shortly that all of this thinking is flawed. This is the thinking, though, that underpinned Ian Hudson's views in the Tobin versus Smith-Kline trial and underpinned Lilly's views when Prozac in the early 1990s ran into problems with people saying it could cause you to commit suicide. So they analyzed their trials and showed that whether you're looking at the depression trials or the eating disorder trials, or whether you're looking at the trials in adults or children, that, again, none of these confidence intervals lie entirely to the right of the 1.0 line. So because of that, they're saying they're not statistically significant, and therefore there's no real evidence that Prozac caused people to commit suicide, as you see the quote down below. Now, what's happening here is that confidence intervals have defaulted into statistical significance tests, partly because regulators and companies and doctors like a stop-go signal, which says, yes, you can go now, or you have to stop. I mean, I should have had green curves here, perhaps, to say you can go. But let me show you something else which is very interesting here, which is this is a schema of the trials that brought these SSRIs, 3 SSRIs, fluoxetine, paroxetine, sertraline, on the market. And you'll see that there's a screening phase here, which is people entering into the trial had to have the previous drugs they were on removed, which put them into withdrawal and makes the washout, a 1 or 2 week washout phase, extremely dangerous. So lots of people go on to a suicidal act or kill themselves in this phase. So when the companies, these 3 companies, send the data on these 3 drugs into FDA, they all did a variety of maneuvers like this. And the key one is look at the people who are in the screening phase. The companies said, well, look, they're not on anything during this period, which is the same as been on placebo. So we'll move the events, not all the people, just the events down into the placebo arm. Now, even when they do this, there's an excess of suicidal events on active treatment compared to placebo. But the confidence interval no longer lies entirely to the right of the 1.0 line. So the companies and FDA are able to say, well, the clinical trials don't show that these drugs cause people to commit suicide. Now, nobody seems to have noticed this around 1990. They did begin to notice it around 2004 when a crisis blew up about children becoming suicidal on antidepressants. And questions were asked about the data that it was now clear had been manipulated. And the company response was, as you see here from GSK and from Pfizer, we didn't hide anything. We were right out in the open. You can now see exactly what FDA could see. And FDA didn't say there was anything wrong with this, didn't ask us to go back and do it all again, which is interesting because these maneuvers do breach FDA regulations. And FDA personnel wrote memoranda saying, we've seen what's happening in these trials and this breaches regulations, but FDA did nothing about it. In the early 1990s, FDA were liaising very closely with the companies about just this issue. So was there criminality? Well, perhaps. But I prefer to see it in terms of strategic ignorance. One of the senior people at FDA at the time, Tom Loughran, even wrote an article incorporating the manipulated data as produced by the companies and giving everybody in the world the impression that these were the accurate data. And he was doing it in an article in defense of using placebo controls in randomized control trials. People had said this was unethical because, people might want to commit suicide on placebo, where they wouldn't do on a treatment that worked. And Loughran is saying, well, there's no evidence that the drugs and placebo are any different. So this is strategic ignorance in the sense that FDA don't create medical knowledge. It's not their job. They're bureaucrats. Companies create medical knowledge for sure. But the people who are probably primarily responsible for creating medical knowledge are, of course, doctors who at this time, with all these events happening, were missing in action. Now, the next 3 slides contain an image of a GlaxoSmithKline document, which is small print and you're not going to be able to read it clearly. I've taken the key details out and put them in bold and bigger type on the bottom there, and that's all you really need to look at for the moment. The slides will be available to everyone, so you'll be able to look at them in more detail later. But the data from GlaxoSmithKline's clinical trials in major depressive disorder, the data they send to FDA shows that paroxetine causes people to commit suicide. Even Ian Hudson would have to agree that it causes people to commit suicide. And these were data that were available to him at the Tobin trial. But randomization comes along to rescue GlaxoSmithKline and Paxil from this problem, which is GSK also did 2 trials in people with intermittent brief depressive disorders, whom you see here. And again, you can see the data more clearly on the bottom line there. And when you add the 2 sets of data in bold there, we come up with the fact that when you add the intermittent brief depressive disorder trials to the major depressive disorder trials together, that we get a protective effect for Paxil in the case of people who might go on to commit suicide. It stops you doing so. Now, what I need to tell you is this. We're using an adverse effect to hide an adverse effect that a drug causes here. And this can happen every time the condition we're treating is heterogeneous. That is a mixture of different conditions. And that includes people who've got dementia and diabetes and hypertension and osteoporosis and back pain and Parkinson's disease and breast cancer. It's true of virtually every medical condition we might be treating. So randomizing these heterogeneous people to a trial means that they're going to conceal some of the effects, good and bad, of the drug that's being used in the trial. Let me show you this in terms of confidence intervals. The major depressive disorder data is up there on the top, and this is statistically significant. There's very little of the data over on the to the left of the 1.0 line. And the conventional wisdom is if we add a few more people in, and in this case, we've added less than 5% of new people into the trial, that we should get a much tighter confidence interval and be much more sure about what we're saying. When we add them in, and the combined group now is the yellow line you see on the left of the 1.0 line, we have a much more precise group, which is what you want, except this precision should indicate to you that we know nothing about what's going on. We know even less than we thought we knew when we had the previous confidence interval. We can add 40 more suicidal events into the IBD group before Ian Hudson would have to say, yes, Paxil can cause people to commit suicide. The other oddity here is if you took 20 Aaron Kesselheim clones and 20 David Healy clones, and the Aaron Kesselheim clones all fall asleep when they take Paxil, and the David Healy clones all wake up and can't get to sleep, and you plot a confidence interval of giving Paxil to them, you'd find that the point estimate, the best estimate we have of what Paxil does, would lie exactly on the 1.0 line. And what's a problem with this is that a method that should help us distinguish between 1 and 2 stars should not give a result which says there are no stars here at all. And this happens every time the responses of people to a drug are heterogeneous, and this is quite common. It really is, okay? The other problem with confidence intervals is here, which is that young men take a drug called finasteride to help thicken up their hair when maybe they're losing their hair. And you could count hairs before and after and build confidence intervals that work in this case. But then this drug has literally 3,500 different effects, among which is that it can cause you to commit suicide or can cause you to have sexual dysfunction, so you will never be able to make love again in your life. Merck say this can't happen, and the reason they say it is that, well, you know, they were looking so closely at the hairs on people's heads that they didn't notice the people committing suicide or they didn't ask about the sexual problems, and therefore there's no precision to the measurement, and the measurements extend right over the 1.0 line, and this lets Merck and other companies in the same position with other drugs say our drugs have no effect. This is the Ian Hudson argument. This is a confidence trick. So I've told you earlier that there are more dead bodies in the SSRI arms of SSRI trials. And Ian Hudson, when he's talking about SSRIs having no adverse effects at all, he's not counting the dead bodies. He's going on rating scale changes, which is, and in this case, it's usually the Hamilton Depression Rating Scale. And here's Max Hamilton, who made the scale. And 15 years later, he's saying, you know, these scales are standardizing clinical interviews, and that might or might not be a good thing. How can not standardizing interviews be a bad thing? Well, up to about 1980, we were in the business of treating the problems that people brought us. After 1980, we increasingly were in the business of giving them problems or helping them, rather than helping them with problems to help them live the life they wanted to live. We were giving them problems and helping them to live the life that Pfizer wanted them to live. And a great deal of that comes down to rating scales, which is on a checklist, which is designed to avoid clinical judgment. It's doing an end run around clinical judgment. It's operational. There'll be items on this depression checklist for suicide. And if I ask you, have you been suicidal recently? And you say you've tried to kill yourself twice in the last week, I'll score a 4. Whereas if the drug has triggered it, I should be scoring a 0. But the checklist doesn't ask me to make that judgment call. It just moves me quickly on to the next of the 20 items or whatever. And this, I mean, these effects happen with half of the Hamilton Depression Rating Scale scores. There should be judgment calls, but there aren't. And so the score will tend to go up whether the drug's causing a problem or the condition's causing a problem. And if the score goes up, I should be increasing the dose of your drug or adding in more drugs and generally helping you to live the life that Pfizer wants you to live. That is, if you don't actually go on to commit suicide because the drug is the thing that's causing the problem. So this brings me on to the industry input to these trials. And a lot of people believe RCTs would be the way, the truth, and the light if only industry weren't involved. I don't agree with that. I just don't think RCTs give us the answers people think they give us. But here's industry input, and this is a wonderful industry trial. It's run in the most distinguished university centers in North America. It's got an authorship line to die for with Marty Keller there as the first author. It's in the journal with the highest impact factor in child psychiatry. It's study 329, and it says Paxil works wonderfully well for teenagers who are depressed and is safe. Now, this article comes out in 2001. 3 years earlier, in the interior of SmithKline Beecham, the company have reviewed the data from this trial and concluded that our drug doesn't work for teenagers who are depressed. But we can't publish that. We're going to pick out the good bits of the trial and publish them. And that's the article you've just seen. When this 6-page document gets into the hands of New York State's Attorney General, he decides to sue GlaxoSmithKline for fraud around the time that there's a crisis building up about kids becoming suicidal on these drugs. This document also plays a part in a Department of Justice action against GSK, which is resolved for $3 billion. And it plays a part in us being able, me and a few others, being able to get access to much more data, well, the data from this clinical trial, much more of it than FDA ever see in any clinical trial that they look through. And ultimately, we got the article published in the BMJ. So, in the original Keller paper, it reports on the first 8 weeks. So we've looked at the first 8 weeks, and here's our data here showing you really can't distinguish any of the treatment arms in this trial. We also published the 6-month follow-up data, which this is published 18 years after the trial had completed. And again, you can see no difference between the 3 different arms in the trial. In the Keller paper, there were 6 children who became emotionally labile. In our hands, there were 18 out of the 93 children taking Paxil, that's 1 in 5, who became emotionally labile. Emotionally labile means that they were suicidal or homicidal or manic or whatever. So let me take you on to a trial that was happening at the same time as ours, which was a Pfizer trial where a man got agitated on the Pfizer drug that he was on. He wanted to kill himself. He poured gasoline over himself, set fire to it, but only died from his burns 5 days later. Pfizer coded him as death by burns. When a person dies in a clinical trial and when they have to go into hospital, companies have to write narratives about what happened, which lets FDA, if they read them, if they find the narrative and read it, know that this really should have been coded as death by suicide. So that's not the issue I want to pick up. What I want to pick up is this, which is that in study 329, there were 4 children where there were events with no narrative at all. One of these children was a 15-year-old boy who, 2 weeks after he goes on Paxil, is out in the street with a gun, waving it around, threatening to kill people. This is unquestionably an effect of Paxil. He's picked up at the police, he's brought to hospital. There should be a narrative report of what happened. There isn't one. FDA to this day have no idea about these 4 children in this trial. There's a loophole that companies discovered 30 years ago, which you can see in the clinical trials published in the New England Journal of Medicine up to the last few months. The loophole is still there. Either FDA don't know about the loophole or do know about the loophole, but are hoping the rest of us haven't spotted it. If you want to know more about this later, ask me. But where I'm going with this is, in the case of people who were coded as emotionally labile, are people who are coded as burns when they should have been coded as suicides, what you've got is an act of authorship. Now, if you look at the 3 sentences over on the right-hand side of that slide, these are the last 3 sentences with which our article ends, and you won't see anything like this in any other randomized control trial article. And what it's saying is, we've got into the habit of thinking of RCTs, the articles which report the results of RCTs, as a bit like Moses coming down from the mountaintop, waving the New England Journal of Medicine tablets of stone, giving us commandments about what we should be doing and shouldn't be doing. Doctors should prescribe this, patients should take. But our point is that when you get to see the raw data, when you get to access the raw data and begin to look at how to author, put it, coming to a view about what's going on here, you find we end up with more questions than answers. The data certainly doesn't underpin commandments, and it shouldn't if we're talking about science. The other area where this comes out is grouping effects, which is in the children taking Paxil, the 93 children taking Paxil in this trial, they had 500 adverse events. You can't report all of these in just one short 10-page paper. You've got to group them, the cardiac events into a cardiac group, the respiratory events into a respiratory group, the behavioral events into a behavioral group. This will be the usual thing. GlaxoSmithKline put the behavioral events into a neurological group along with headaches and dizziness, which are terribly common. And when you do this, it drowns out the signal from the behavioral events. If you take them out and put them back in a behavioral group, which will be the usual thing, the signal that there's a problem with Paxil stands out like a sore thumb. But BMJ, interestingly, had awful problems with us not using the coding dictionary that GSK had used, which FDA didn't know about it, which no one else has access to. We used the standard coding dictionary and not grouping things the way GSK had grouped them. The trick is, once you code them the way GSK had coded it and group them the way GSK grouped them, the paper almost authors itself. And BMJ didn't want there's the data, then there's the interpretation of the data, and GSK didn't want us to interpret the data in any way other than the way GSK had interpreted it. And there's no scientific experiment that doesn't involve interpretation, and it's not clear that GSK interpreted this stuff in the only possible or even the best possible way. So everybody knows that the only SSRI that was approved for teenagers was Prozac. But this is a letter from FDA approving Paxil. It's to GSK approving Paxil for teenagers. And it says, you have told us that study 329 and these other 2 trials were negative, and we agree with you, but we're still going to approve Paxil. They did the same thing with Prozac, in fact, which is they had viewed the trials as negative, but they still approved Prozac. They also say, we agree with your suggestion that it would not be useful to mention this in the labeling of the drug. So these are data from a paper by Eric Turner, which looking at the publications of the controlled trials of antidepressants for adults. And, they're wonderful. They look great. All these trials say the drugs work wonderfully well and are safe. You'd almost feel like rushing out and putting yourself on one of these drugs. Look at the column 3 from the right, the sertraline column, the one that says 61 and 62. You've got to have 2 positive trials for FDA to approve your drug. Now, Eric Turner didn't just get hold of the academic literature. He had worked in FDA. He knew there were FDA reviews of these drugs. And when you look at the FDA reviews of these drugs, you find that almost half, 46% of the trials overall were negative. Some of the negative trials were never published, which is fine, but 1/3 of the previously positive trials were published as positive by the company, viewed by FDA as negative. And look at the 3rd column from the right, the sertraline column, which has now only got 1 positive trial, and you've got to have 2 to be approved by FDA, which is interesting. But why are FDA saying nothing about all this when the companies publish data like this? Well, it must be clear from the study 329 example that there's a risk if FDA said in the label of the drug not all these trials were positive, that companies could get sued for fraud, like GSK were, or fined $3 billion, the way GSK were. So FDA, in a certain sense here, have gone missing in action, it seems, and I'm going to try and explain this, but on the way, let me point this out, which is Pfizer did 4 trials of Zoloft for PTSD, all negative, but FDA still approved it. They approved it on the basis that 2 of these trials had a marginal benefit for women only. And these 2 trials have been written up, as you see, under the status heading there, the 2nd box. It says one is going to go to the New England Journal of Medicine and the other is going to go to JAMA. Over on the left, it says TBD, to be determined. Pfizer's marketing department are going to pick the names that they figure are going to be best in terms of the sales and marketing of Zoloft for PTSD. What you've got is a situation where across medicine, it's not just antidepressants, it's any of the drugs we use, any on-patent drug is ghost written. The authors on the authorship line are not the authors. Neither they nor the ghosts will have seen the data. But in the case of children, we know that 100% of the trials were company written. We also know that this is the greatest divide between what the publications say these drugs work wonderfully well and are safe and what the raw data says when we get access to it. The greatest divide, not just in medicine, but possibly in all of science. Where's FDA in this? Well, FDA are wondering about chocolate. Some of you may know that the UK joined the European Union 50 years ago and immediately ran into problems. The pesky Europeans told them that, you can't call your favorite Cadbury's chocolate chocolate. There's not enough cocoa solids in it. And this is what led to Brexit 6 years ago. FDA, like the European Union, regulate food and drugs. They regulate chocolate in terms of a cocoa solids standard before you can use the word chocolate, or butter in terms of an animal fat standard before you can use the word butter, are antidepressants in terms of a small drop on a Hamilton rating scale score. It's not save lives. And if you've got that, you can use the word antidepressant. FDA don't say this is good chocolate. They don't say butter is good for us, and they don't tell us that antidepressants save lives, and they don't police the medical literature. It's not their job. But what they are doing lately, since the SSRI and suicide crisis blew up, is this. They tell us that they approve drugs on a benefit-risk basis. Now, if FDA were approving parachutes, and we have 20 people who had a parachute who are alive at the end of the jump, and 20 dead bodies on the ground, people who hadn't got the parachutes, we could agree there's a real benefit here. And we know that some men who had the parachute may not be able to make love properly for a week or two after the jump because of the harness effects. So there's a hazard, a risk here. But overall, everybody would agree there's a favorable benefit-risk ratio. In the case of the SSRIs, however, there are more dead bodies on the SSRI. And in particular, 30 minutes after your first pill, everybody's going to have genital changes. And while you remain on this drug for the period of time that you're on it, you're not going to be able to make love the way you would normally make love. And you may be hoping to get off the pill when you'll be able to get back to making love normally, but many people simply can't get off the pills at all. And even if you do get off them, you may never be able to make love properly again. So how FDA can claim to be approving drugs on a benefit-risk basis is beyond me. Particularly when you remember that companies have been able to game trials. They knew these things were happening before the treatment trials started, and they could game the trials to make sure that the sexual issues didn't show up. So let me tell you about a man I was treating some time ago who had OCD. And the standard first-line treatment for OCD is an SSRI. So we put him on an SSRI, and that didn't work, and we put him on a more heavy-duty drug, and that didn't work. This was a heating engineer who needed to get his OCD job. A few weeks later, he comes back to see me. He's stopped all the drugs that I put him on, but that's not what's cured him. He's taken up smoking again. And now, I often say to people, look, the art of medicine is bringing good out of the use of a poison, and people hiss at me when I say this. But in this man's case, you probably agree with me. He was bringing good out of the use of a poison that's available over the counter compared with the SSRIs that are available on prescription only, because we've every reason to think they're more hazardous than nicotine and alcohol. But that's not my point. My point here is that the person who's in the best position to make a benefit-risk call is the individual. This man on nicotine compared with SSRIs, he figures nicotine is a much better benefit-risk call for him. Benefit-risk calls have to be individual. FDA can't make them on average data. If they try to do it, they're getting you to live the life Pfizer and GSK and Lilly want you to live rather than helping you to live the life that you want to live. Now, you may be thinking, is Healy sort of putting too much weight on citizen research, compared with the experts who are doing the clinical trials? Well, this man, interestingly, had gone ahead and Googled nicotine and OCD and found there were a number of studies showing that nicotine's really beneficial for OCD, and he handed me the articles, and he didn't know any medicine as such, but so he didn't spot that one of the articles, one of its authors was Arvid Carlsson, who won the Nobel Prize for Medicine, and who created the SSRIs, and he's there saying nicotine is a good treatment for OCD. So citizen research can be just as good as Nobel Prize winning research. When you've got skin in the game, we end up with a situation that motivation can be just as good as expertise. So here's an article that I wrote 25 years ago, which says, if we go by Ian Hudson thinking, which our RCTs have shown our drugs have no adverse effects at all, everybody who enters into a clinical trial and is injured by drugs is putting everybody else in a state of legal jeopardy, and we should stop volunteering for company clinical trials until this changes. Here's an article from 25 days ago where I'm saying, look, if you look at the consent forms for company clinical trials at the moment, they seduce you into the trial by saying, if anything goes wrong for you, we will cover all your expenses. We've got insurance policies. There's no problem. You will be looked after by the very best people. But of course, nothing goes wrong in a company trial. You aren't injured. You aren't killed. And this is a lie. There's one place where Ian Hudson thinking doesn't apply. And this is if you're an investor wanting to look at the adverse effects of a drug to work out what the risk-benefit ratio of a drug generally is going to be and whether you should invest your money in the company that has this drug. In 2010, the United States Supreme Court said if you're investing your money in this, you have a right to see the adverse effect data and make up your own mind about what they show rather than go by what Ian Hudson tells you. So we now come to the telltale heart of this talk, which happened in Boston 33 years ago this month, where 3 Boston clinicians reported the case of 6 people who got on Prozac and become suicidal. And by all the canons of medical causality, they nailed it. There was no doubt about the fact that Prozac made these people suicidal, at least most of them anyway. And within a year, there were at least 20 different reports from groups all over the place, including one by me, which said exactly the same thing. We've given Prozac to people and they become suicidal. You stop the drug, the problem clears up. You put them back on the drug, the problem reappears. Now, in almost the same week as my article came out, Lilly produced this article in the BMJ saying, we've analyzed our clinical trials and there is no evidence that Prozac causes people to commit suicide. So all these reports you're seeing from people like Martin Teicher and David Healy, well, they're very sad reports, but they're anecdotes. And the plural of anecdote is not data. It's depression that makes you suicidal, not Prozac. And the challenge to everybody that they threw down was, RCTs are the science of cause and effect. Are you going to believe the science are the anecdotes? Now, this is the article that creates evidence-based medicine in contrast to the evidence-based medicine from the Teicher article and the Healy article. What I've shown you is that Lilly cooked the books, and when you get access to the raw data from their clinical trials, you show that the clinical trials show that Prozac can cause you to commit suicide. So there's no incompatibility from an evidence-based medicine point of view between the evidence-based medicine that's reported and the clinical trials, which is fine. But even if there were an incompatibility, let's say the trials didn't show a problem and the clinicians reporting on cases they were seeing said there is a problem, that incompatibility isn't a problem. It's the essence of science to try and work out how we're getting 2 points of view, what's actually going on here. In contrast, Lilly, who are claiming to do science, aren't. They're doing religion. They're doing infallibility. They're saying there's only one way to look at this, our way, and other people who think they're seeing problems aren't seeing problems. This is papal infallibility reinvented for the modern era. Or, as Peter Drucker, the doyen of marketing, would have said, the goal of marketing is not to sell Prozac. The goal of marketing is to own the marketplace. And this is the article that gave pharmaceutical companies, not just Lilly, ownership of the marketplace. So I've contrasted religion and science, which takes us back to the question of what is science? And the conventional histories say it started here in 1660 with the foundation of the Royal Society, who famously said, we're not dealing with theological questions or philosophical questions or the meaning of life. We're dealing with questions that can be settled by data. Whether you're Christian, Hindu, atheist, Muslim, or Jew, you've got to leave all that stuff at the door and come in and look at the experiment taking place in the apparatus in front of you and come to a consensus view about the best way to explain that. Now, when this history is told, the emphasis from the phrase settled by data is usually put on the word data. This is wrong because there were events, but not data. There is no statistics in any of the experiments that were happening in the Royal Society or anywhere else for 200 years or more. people were being asked to give a view about events. But my emphasis, I mean, I think the emphasis has to be on the settled by, which is you're asked to come to a consensus view about the best way to explain this. And there was an event 40 years earlier, which helps bring this home, which was Walter Raleigh was executed for treason, being too close to those pesky Europeans. And after his death, the English legal system recognized he'd been convicted on the basis of hearsay. That is, people said things about what he'd said or done, but they weren't prepared to come into court to be examined and cross-examined. And the new rules of evidence were that a jury of Christians, Hindus, Muslims, atheists, and Jews were told, you got to leave all the baggage at the door, come in and make your mind up on what you're seeing in front of you, the examinations and cross-examinations you see right in front of you. And that's the essence of science. But, so let's say 30 years ago, Aaron Kesselheim had come along to me and said, look, I'm feeling off color. What about that new drug Prozac? And I gave it to him, and he comes back a week later saying he's feeling weird and maybe suicidal. So we halt the drug and the problem clears up. And if we're really brave, we might reintroduce it again for a bit and see if the problem comes back. And he and I know each other quite well, and I've got all his medical history and lab results and can do more if need be. And we can do a case conference with all of you here. And you're free to ask any questions you want and generate ideas about what might be going on. If the conclusion is that Prozac is the likeliest explanation of what we're seeing, Aaron and I might decide to send a report in to FDA. And the first thing FDA will do is to strip his name off it. The next thing, let's say 30 years later, one of you comes along to me and I put you on an SSRI and you become suicidal and you want to sue me. And you say, well, look, there's tens of thousands of reports of people becoming suicidal on these drugs on FDA's website. My lawyer will get up and say, well, that's just hearsay. You can't bring it into court. It's not evidence. If Aaron and I had written an article in the New England Journal of Medicine or the American Journal of Psychiatry, like the Teicher article, with our names on it, you could bring both of us into court to examine and cross-examine us. That's evidence. Company trials aren't evidence either. They're hearsay. We don't have the names of any of the patients. No one can be brought into court. We know that a lot of them don't exist. We know that the authors on the authorship line of these papers have never seen any of these patients or any injuries happening to any of them. It's all hearsay and should not be admitted as evidence. Now, here's Louis Lassagne in mid-career, the man who's responsible for us doing RCTs. And the idea is just beginning to emerge around the early 80s that RCTs are the scientific way to establish if a drug has adverse drug reactions. And Lassagne is saying this is baloney. He's got this gorgeous use of the word sophisticated in here, but he's saying this is baloney. The way Healy and Kesselheim went about it, that's the scientific way to do it. And here's Lassagne 15 years later, at the end of his career, saying, in the 1950s, I went around the place telling everybody, you should be doing controlled trials. But now I realize that this is useless. It doesn't tell me anything about what to give the person right in front of me. Controlled trials give us what Hill said, whereas these average effects, which, are maybe totally irrelevant for the person in front of me, both in terms of what might help them, but also if they're having an adverse effect, the controlled trials don't tell me anything useful. They produce an orange glow. Which brings me back to the James Webb telescope, which you saw earlier. And I'm sure all of you have thrilled to the images that have come from the early universe, the stars that were there then. And the whole point behind the use of confidence intervals once upon a time to help astronomers get a better fix on the distinctions between stars is that it promoted an individuality. We're no longer seeing an orange glow, we're seeing stars in their individuality. And we've got the idea more recently over the last 50 years or so that part of the progress here that led to the James Webb image that you see here is we've been using chance to control bias. And that's where we get objectivity from. But it's not. What you see from the first 300 years of science, what you see from law, what you see from clinical medicine is science is all about using bias to control chance. That's where objectivity comes from. And this becomes terribly important when numbers come into the frame in any way at all. Up to about 1980, we were treating people who came along to us with heart attacks and strokes and psychosis, trying to solve problems to let them live the life that they wanted to live. They were really ill. Since 1980s, companies have realized that they can treat healthy people. They can treat numbers that are a little bit abnormal, for which their drugs appear to be the answer. And this is where they make 90% of their money these days. Treating the diseases we want to get eliminated so that we can live the life we want to live is not what companies do these days. And the weighing scales here brings it out beautifully, which is weighing scales for people were introduced in France in the 1860s. 10 years later, there was the first descriptions of a new illness, anorexia nervosa. 40 years later, weighing scales migrate into drugstores with a plate on the front of them giving your ideal weight for your height and sex. An eating disorders mushroom. 40 years later, weighing scales migrate into our bathrooms, and eating disorders explode in the countries that have weighing scales for people and not elsewhere. Numbers can make both doctors and patients neurotic. There's a chance you may still be able to maintain control in the whole situation if you're not being told that you can't use your judgment. Your judgment is being replaced by an algorithm, by confidence intervals and statistical significance. If that happens, we create medical neoliberalism. Let me explain that a bit more. Coincident with companies beginning to treat numbers rather than people, healthcare changed into health services. Beforehand in healthcare, a doctor's judgment, a bit like a judge in court, was at the heart of the exercise, and the doctor's job was to mobilize the resources of the organization he or she worked for to help the patient who had come along. Once we got managers, the idea of bringing good out of the use of poison didn't compute for managers. Managers are in all service companies. When health became a health service industry, it got managers who had no clinical background at all. And the feeling patients had when they came along to the services changed from seeing someone mobilize the organization to help them into someone who figured they had to manage the risks the patient posed to the organization they worked for, which is not care. Managers and technocrats, this is not just management, it's the technocratic approach, manage what they can measure. And just like in the case of managing the money supply numbers or the inflation numbers in Chile or England, this was neoliberalism, the origins of it. You manage this and get the numbers right, to hell with what's happening in the country. In the same way, we're managing patients' numbers, to hell with what happens with them. And one of the key things that happens is that they end up on more and more drugs. We're producing numbers that to managers have a sheen of scientific gold in health services, but this is the King Midas story all over again. The sheen of gold is incompatible with human life. So there's three people here. The lady in the middle is a pilot. If she sees things going wrong, she reports it, and the system responds because they know if they don't respond, she's not going to fly again. The lady on the right is Jane Fraser, who's the CEO of Citibank in New York, who began her rise to the top during the financial crisis. Banks now have an early warning system. Nobody really knows if that makes any difference or not. The heart of the financial crisis was bankers outsourcing risk, giving us mortgages they knew were dodgy, but if the mortgage blew up, it's us who are going to be injured. The bankers still collected their pay. This is a position of moral hazard where it's difficult to do the right thing. The lady on the left's a doctor. If she reports an adverse event she sees, the system dismisses it, pays no heed at all. She too is in a position of moral hazard. She gives us dodgy drugs that, like dodgy mortgages, well, she doesn't know if they're going to work out. If they blow up, though, they're going to injure us. She's going to continue to be paid. This is a situation of moral hazard that makes it terribly difficult for a doctor to do the right thing, particularly if it involves a certain amount of bravery. And as with the financial crisis, we're heading toward a pharmaceutical crisis. This is a life expectancy graph in the United States stemming from, which came from the New York Times. And if you look at the data from 1980, when we began treating numbers and when we converted from healthcare to health services, you see life expectancy falling. And this is all pre-COVID and pre-vaccines. My view about what's going on here is it's polypharmacy that's causing the problems. Drugs are like guns in a few respects. One is they both create an arms race. The country that has the best arms and the best drugs wins wars. So the military in the United States in particular has had a huge input, not just into the development of nuclear bombs, but also into the development of health services. Drugs, like guns, have a limit to their effectiveness. We can produce bombs that are so effective we can't use them. In the same case, we can produce 30 or 40 drugs, but if we put you on 30 or 40 drugs, they're going to kill you. They're not going to save you. There's a difference between drugs and guns in that the guns actually do get better the whole time, even though we end up not being able to use them. In the case of drugs, the chemicals don't get better. What gets better is the propaganda, the information we're supposed to depend on. And this is in the case of drugs, this is the most effective propaganda there has ever been. It's become invisible, as all good propaganda should. It masquerades as science. Drugs and guns aren't moral in themselves. Whether we bring good or bad out of them is down to us. In the case of propaganda, it's not clear that we can ever bring good out of it. It's not clear that it doesn't just do bad. But in terms of the life expectancy falling, the view now is that if you go up to more than 3 drugs a day, you're not going to get the effectiveness from them that you get from each of them on their own. So over 3, you're beginning to give yourself problems. 6 years ago in the United States, 40% of over 45s were on 3 or more drugs. 40% of over 65s were on 5 or more drugs. Many people are on 10 or 15 drugs. And we know that if you can get the 10 or 15 down to 5 or 3, that we're going to reduce the right to go into hospital. We're going to reduce, we're going to increase your life expectancy, and we're going to improve your quality of life. But getting you off 5 or 10 drugs isn't easy, as this still from the Hurt Locker shows. You know, there's never going to be randomized control trials which will tell you the answer here. There's never going to be guidelines that tell you the answer. It's going to depend on the clinical experience of this doctor here to try and get you off of the explosives that you're currently on, some of which you simply won't be able to get off. If he or she has been there before, that helps. If he or she is a walkie-talkie and can talk to colleagues, that might help. But the critical person for them to liaise with is you if you're on these drugs. You'll have missed 1 or 2 here or there. You'll have known the ones that it looks like you can stop and the ones that you can't. You'll have values that we need to take into account about what you want to be able to do ultimately with whatever drugs you're left on. You know, we don't want to remove a drug that's actually helping you. Your key to all this, relationship-based medicine, is more important than evidence-based medicine. But there's a further problem getting in the way, other than just the absence of controlled trials, which is public health systems came into being because it was once the privilege of wealth to get on treatment to save your life. And because of that, public health systems in Canada and Europe want you to have more and more drugs, more and more diagnoses. This sounds like it can only be a good thing, up to and including what they've now got, which is medical assistance in dying, where Canada leads the way. I don't have a tremendous problem with MAID. I mean, there is a problem with young women getting MAID because they've got treatment-resistant depression, having been put on 10 or 12 psychotropic drugs that create the illness that they then get MAID for. My moral problem is with a system that will give you everything you want up to and including MAID, except the option to get off some of these treatments in order to save your life. It is becoming a privilege of wealth to get off treatments to save your life. So this brings me to the end, which is this from an Arthurian legend. And King Arthur is out in the forest one day and meets a black knight who challenges him to a duel and beats him and is about to kill Arthur when he says, I've got a better idea. I'm going to give you a riddle. What do women most desire? And if you can come back with the answer in a year's time, you live. If you don't have the answer when you come back, you die. So Arthur goes off back home and sends his courtiers out to look for the answer. But a year later, they still don't have it, and they're on their way back to meet the Black Knight. And they meet this lady who says, I have the answer to the riddle you've been asked, but you're going to have to give me one of your knights as my husband for it. So Sir Gawain gets down and says, I will be this lady's husband, Your Honor. And she gives Arthur the answer. He gives the Black Knight the answer, who reluctantly lets Arthur go. So they go back to the castle, and a few days later, Gawain is getting married to the Lothry lady, and you can see that people are there looking very glum and wondering what's going to happen when they go up to the bedchamber. And when they go up to the bedchamber, Gawain can't bear to look at her. And she takes control and taps him on the shoulder, and he finds an extraordinary woman. She says to him, she gives him a riddle. She says, do you want me to look like this in the bedchamber with you at night and the way I was looking during the day in court? Or do you want me to look like this during the day in court and the way I was looking in the bedchamber with you at night? And he has no idea what the answer is and says, whatever you want, which is the answer to this riddle and the previous one, which is she, like all the rest of us, want to control our own lives. We may have a problem that a doctor can help us with, but we may know much more about how to live life than the doctor or anyone else in the health system that we attend. If this doctor is going to help us with the problem we have, there needs to be a continuity in the relationship. He needs to look at us, or she needs to look at us and listen to us closely, and maybe even be able to detect a change in our smell from the previous time that they've seen us. This is science. We are the apparatus in which the experiment is taking place, and we need to get a consensus view between the person looking at us, trying to work out what's going on, and us who are living with these issues. This is the essence of science. This is a relationship-based medicine. If we're not doing this, we're not doing science. If we're not doing this, we're not doing democracy either, which is government of the people, by the people, rather than the people being governed by numbers.